Hey everyone, so the goal for class 68 was to find the relationship between wavelength and frequency. So for the do now activity, we're actually doing some stuff we did back in class 67, measuring frequency and measuring wavelength. So the first thing here says your classmate creates a standing wave by moving her end of a rope up and down 10 times in a span of 4.5 seconds. What is the frequency of the wave she's creating? So that's something that we actually did in this activity, so this is a good warm up for that. So remember, frequency is number of oscillations per second. So if we have frequency equals, let's see, so 10 oscillations in 4.5 seconds, that comes out to be about 2.2 hertz. Now for the next part, you have to identify the number of wavelengths and then the wavelength. So the number of wavelengths is, for this first one here, let's see, that's half of a wave. Okay, because there's only there, it's only like a hump. It doesn't have the second half of it that comes back up. All right. So if that's half of a wave and that's 3 meters long, that means a full wave must be twice that. So it'd be 6 meters, the wavelength of that one. We'll see this next one, number of wavelengths. That's one wave. Next one, let's see, there's one wave and then a half wave. So there's 1.5. And the last one, there's one wave and there are two waves, so two waves there. So for this one, the second one here, if there's one wavelength there, and that's 3 meters long, a wavelength must be 3 meters long. For the next one, if there are 1.5 wavelengths there, and let's see, it's a total of 3 meters long, you do 3 meters divided by 1.5, and you'll get 2 meters. And for the last one here, let's see, we have two wavelengths, and that's 3 meters long, so each wavelength must be 1.5 meters. So just to reiterate what we're saying there, and I'll just change colors for a second. This distance right here, one wave, that's 1.5 meters long. Because the whole thing, both of these waves together, is 3 meters. So we see one wave, we see a second, it's 3 meters long total. Each one has to be 1.5 meters long. So this kind of starts to introduce the activity we did. It says you should be able to calculate all these things using your own rope spring. Your goal for this activity will be to find the relationship between wavelength and frequency, no peeking at the reference table. We need to keep the rope and the spring constant. How can we do that? So some ways we said we could keep it constant is constant distance between you and your partner, same length of rope, and another thing we mentioned, I'll throw it over here, was same amplitude. The setup procedure just lists a couple of things that you had to do to keep all these things constant. So let's check out the next page. So here's your data table. I left it pretty blank on purpose. A lot of people are asking, well, what do I put in these two columns here? Well, what are we comparing? Wavelength and frequency. So let's throw those in. So frequency, which is measured in hertz, and wavelength, which is measured in meters. All right, actually this worked out pretty much identical to the previous, to the do now, because what we did was we made the distance between the partners the same. We made it 3 meters. So for this first one here, the wavelength was 6 meters. This one was 3 meters, 2 meters, and 1.5 meters. Now the frequencies you calculated, what you should have noticed was that as the wavelength got shorter and shorter, the frequency had to get higher and higher to create these different standing waves. So I don't remember what they were exactly, but let's say this one was like 2 hertz. This one was 4. This one was 6. And this last one here was 8. Then I asked you to plot the two. It didn't matter which one you put on which axis. Let's just say frequency was here and wavelength was here. Again, it doesn't really matter which one you did where. You get the same shape. You should have got a nice inverse relationship that looks something like that. So claim, you should have written this as a sentence, but basically as frequency goes up, wavelength goes down, or as frequency goes down, wavelength goes up. Reasoning, you could have said a couple things. You should have either mentioned your data, okay, and actually mentioned specific data points, or you could have also mentioned your graph, the shape your graph took, that it was an inverse relationship.